Natural gas derricks are a slice of America, iconic reminders of this great country's history and its future. And while just about everyone knows what a drilling rig looks like, most people would be astounded if they saw up close and personal the amount of machinery, manpower, skill, and science used 24/7 in drilling for clean-burning natural gas. There's a lot happening at a rig site. It's hard to know exactly what's going on. So today, we're giving you a special VIP rig tour, so you understand the workings of a rig. As we conduct our tour, we'll have some help from Mark Bottram, Chesapeake Energy Field Superintendent, and Travis Striplin, NOMAC Drilling Asset Control. They're both rig experts with 30 years in the natural gas industry between them. They know just about all there is to know about drilling rigs. So let's start our tour before rig construction even begins. First, geologists analyze an area, often using seismic technology to pinpoint the very best drilling locations. So once a drilling location has been chosen, site preparation starts by clearing a road for access to the rig site. Then comes the creation of a plastic-lined or concrete pit to hold rock cuttings and drilling mud once the site is up and running. Now, this pit will protect the ground surface during drilling. The next step is preparing for construction of the actual rig.
This is the pad where the rig will eventually come and set. We've got the rat hole that'll be drilled pretty soon. The conductor will be set down here, and the mouse hole will be drilled as well. The rat hole houses the Kelly, which is used in the drilling process. It rotates the pipe and rotates the bit and drills the well. The mouse hole will be where the next joiner drill pipe is stored in the drilling process. Then we'll drill the conductor, and that's exactly where the well will appear and will be drilled.
So now that the site is ready, the rig and equipment are brought in, launching the 3 or 4 day rigging up process. It's a big operation. The average rig requires 50 to 75 people and 35 to 45 semi-trucks to move and assemble it. There are two kinds of rigs. One's a traditional rig, which is assembled on the drill site. The other is a trailer-mounted telescoping rig. It's also called a carrier rig because it's carried to the site on a truck fully assembled. One big difference between the two rigs that you'll notice right away is the rig site itself. A traditional rig sits on about 3 acres, while a trailer-mounted rig site is about half that size. So there are two ways rigs can be powered, by electrical or mechanical drives. Now this traditional rig is electrical. Let's see how this rig runs.
This is the engine generator house. This is where all your power of electricity is produced. This particular rig is made up of 3 engine generators. All 3 together can combine up to 4,000 kilowatts of electricity. That's enough electricity to supply a small town.
Where's the electricity going? Into the SCR house. That stands for Silicone Controlled Rectifier.
From the engine generator house, all the power goes to the SCR house. From there, it is distributed throughout the rig to any electrical component that needs it.
Electric rigs can also run off highline power, electricity drawn from power lines. Now, doing this helps limit noise from engine generators when rigs are located near residential areas. Another advantage of highline power is that electricity is less expensive than the diesel fuel used to power generators. On mechanical rigs, you'll notice that individual diesel engines power each piece of equipment. These mechanical rigs are an older technology, but are still highly effective and popular. So now that you know how the parts are powered, let's start talking about the equipment that makes drilling possible. We'll begin with a mast. It's probably the most identifiable part of a rig. A traditional rig has a cantilever mast. It's about 136 feet tall. A carrier rig's mast is shorter than a traditional rig's. It's only about 118 feet tall.
The mast on a trailer-mounted drilling rig like this one remains permanently attached to the rig while it moves. Once it's here and backed up to this platform, 2 large hydraulic cylinders will raise that mast up to the vertical, and then it is extended to its working position.
The masts on both rigs sit atop the substructure. A traditional rig substructure looks like this. It's a steel box support system. You'll see something entirely different on a carrier rig.
It's easy to see the difference between a traditional sub box on box compared to a trailer mounted drilling rig like this one. This one uses a platform that is simply scoped up, pinned into place, and the truck that delivers the rig to location will be the one that backs it up to that platform and simply pins it in place.
So as you heard Mark mention, unlike the traditional rig, the trailer-mounted rig is trucked into the site fully assembled. Now, in both types of rig styles, the mast, drawworks, and traveling equipment, or blocks, allow the crews to raise and lower sections of the tubular equipment like drill collars, drill pipe, and short sections of pipe called subs.
The pipe is raised and lowered by the traveling blocks. That's the large yellow piece of equipment hanging in the derrick. It's driven by the drawworks. That's the large blue piece of equipment sitting on the rig floor. That's a National 110 UE, an electric drawwork. It's rated 1,500 horsepower.
Well, there are two ways to drill for natural gas, vertically and horizontally. Now, vertical is just like it sounds. That's drilling straight down. But in horizontal drilling, the drill is actually propelled parallel to the ground surface by using special tools and drill bits. Horizontal drilling has become one of the industry's most valuable and popular technologies because it allows better penetration into what's called the pay zone. Now, that's the area where the biggest concentrations of natural gas are. Now, either way you're drilling, operations are basically the same. You go through three stages. There's drilling, running and cementing new casing, and then drilling again until the bit reaches the depth selected by the geologist. It's known as the TD, or total depth. Now, for the first phase, drilling, the rig uses its engines, drive systems, and rotating equipment to turn the entire string of drill pipe that can be up to 5,000 feet long. Now, that pipe, in turn, rotates the bit at the bottom of the hole.
The actual equipment used in the drilling process consists of the Kelly bushing, and the rotary table. There's an engine that drives the rotary table, which turns the Kelly. The Kelly is directly connected to the drill bit through the drill string, and as the Kelly turns, hole is made.
A drill bit can last from a few hundred feet to 5,000 feet of drilling or more. Now, when the bit needs to be replaced, the entire string of drill pipe has to be moved. Called making a trip, removing pipe is a process that can take several hours or days. And once the bit is replaced, pipe goes back in the hole, and that's called making a trip too.
When someone refers to tripping in or tripping out, a trip or a bit trip, what that actually means is penetration rate is probably slowed down. The bit needs to be looked at or replaced. The drawworks will hoist the blocks. That's the hoisting mechanism that will trip out each stand of pipe. It'll all be set off to the side. When they get to the bit, at the end of the string, it'll be inspected and probably replaced. The operation will then be reversed. They'll trip the drill collars back in, trip the drill pipe back in. Once they get on bottom, they'll start rotating and drilling again.
When pipe is tripping in, the auxiliary braking system is used to keep pipe from going in the hole too quickly. When you're on a rig site and pipe is tripping in, well, you'll know it, as the auxiliary brakes are pretty loud. So as you drill, the heat on the bit is very intense. So drilling fluid, or mud, is constantly used as lubrication. So imagine WD-40, only a lot more of it.
Before the mud can be used down hole as a lubricant, it starts here in the suction pit. In the suction pit, this is where your various additives are added to it for viscosity and weight. From here, it gets sucked out through your mud pumps at a high pressure. It will be forced up to the drill floor to your standpipe. As your drilling fluid, also known as your drilling mud, reaches the rig floor, it goes through a series of standpipes all the way up to your board, to your what you know as the Kelly hose, which in turn travels all the way down through your drill pipe, out through your drill bit. Then your mud travels down the flow line, which in turn goes over your shell shakers. From your shell shakers, the debris is taken out of your mud, which is then ends up in your shaker tank. From your shaker tank, it goes through various cleaning equipment, such as your desilters and desanders. From here, the process starts all over again in your suction tank, where the additives are added to it again.
So now, it's time for the second phase of operations. That's running and cementing new casing. Now here, the crew inserts several joints of steel pipe called production casing. Now the casing runs the entire length of the hole and is cemented into place.
Casing is basically just a string of pipe, also known as the steel highway. It's implemented throughout different stages of operations. What it allows is your drill bit to travel through more efficiently, thus making operations more efficient.
So once the casing is cemented into place, drilling resumes until the well's total depth is reached. So there's one important part of a rig that everyone needs to know about because it's a lifesaver. It's called the blowout preventer. It's also called the BOP or stack.
The blowout preventer, sometimes referred to as the stack, plays a critical part of the drilling process. If we drill in and create excessive pressures downhole, that pressure will sometimes want to come and meet us at the top of the well. We've got to keep that isolated for safety purposes. It's called well control. This blowout preventer has 3 elements on it. It has a set of blind rams, a set of pipe rams, and an angular device, all activated by the accumulator. The blind rams will close and seal on themselves if there's nothing in the wellbore. The pipe rams will seal around the pipe if there's pipe in the hole. The angular will close around anything. It's a rubber bladder. It'll conform to wire rope, wire, cable, whatever might be downhole.
So we've been talking to you about a lot of equipment on a rig, but it's important to note that not all of it is owned by the rig operator.
From time to time on location, you're going to find rental equipment, such as downhole equipment, dryer units, and igniters on the side of our locations.
Drilling on a carrier rig lasts from about 15 to 20 days. On a traditional rig, drilling lasts longer, probably 90 days. And when it's time to head to the next well, a traditional rig is disassembled and taken to another location. Now, the trailer-mounted rig gets hauled away behind a truck. And once the drilling is over and the rig's removed, it's time for the production process to begin. Now, eventually, a production wellhead called a Christmas tree will be installed on the well. When all is said and done, the natural gas will flow from the wellhead into the pipeline. Maybe you're not quite a roughneck yet, but you do have a better idea of a rig's machinery and how each and every part is so important in drilling for the fuels that help us enjoy so many modern conveniences and necessities. Thanks for coming on our rig tour. We're going home, but the work out here continues.